I have no idea, because this one was supposedly to be, this is mine, the other one was them, but the bulb was brand new, so I guess it was a cheap bulb. In any case, now we're back into speed, so. All right, so we talked about it, that we have a relationship between current and voltage associated to the module. And a lot of that information, we have to show what the relationship is as voltage increases or decreases. And then we're going to talk about the relationship with respect to the temperature and so forth. So we're plotting curves. So typically, guys, let's settle down for a second, please, so this way we can proceed. So when we look at an actually, what we call it an IV curve for a particular module, you see actually the output profile of an actual panel itself. What does that mean? Because sometimes just descriptions is... What happens if you notice in here, if you notice in here is, as you're increasing the voltage in here, as the voltage increases in here, it reaches to a certain point, we call it what? The open circuit voltage. So we take the module up here, okay, and we're measuring something which is called the open circuit voltage in here. At the same time, if we take the module and we short it together, okay, we're measuring the short circuit current associated with that. So we plot it, okay, we can see that when we short the circuit, we have a certain amount of current associated with that, and the current remains what? Pretty much what? Constant in here until it reaches what? This point in here. And then it starts what? Tilting down. At this particular point, okay, at this particular point, what would I get? At this particular point at the knee, what is called the maximum what? Peak current and the maximum peak voltage. So at this particular point, I would get what? My maximum power point. So some of the information that I get from the manufacturer is going to be a specification indicating what? The open circuit voltage, because it's the open circuit voltage under what? What kind of load? What kind of load do we have in an open circuit voltage? Infinite, right? There's no load of it, infinite. And what happened to the short circuit current? What kind of load do we have? There's zero resistance practically, right? So the short circuit current, so one of the specifications that the manufacturer would give you, it would be the short circuit current as well as the open voltage current. With the knee, just at the point of the knee, we have identified here what? The maximum power voltage as well as what? The maximum power current. That is very important. So if you look at your book in here, okay. So if we look up here, this the open circuit voltage is the maximum voltage on what? At the curve. Okay, and it actually defines the operating curve point for a device under what? Under what? Infinite load, open circuit condition, no current. Okay, no current. Since you have no current, what you have is what? The power at that point is zero. Okay, so the open circuit voltage is what? It's the maximum point voltage that you will get. Under what type of condition? Under what kind of condition do you measure this particular what? Voltage. Most of this what? We said before that the standard that we're using is what? 1,000 watts per square, 1,000 watts per square meter of irradiance. Okay? This is what is called a standard test condition, and actually we had defined that at what? A temperature what? 25 degrees what? Celsius. Okay? Remember that. So if I take a panel and stick it in the front of what? Of a laboratory and shine up there 1,000 watts per what? Per meter square, and measure the open circuit voltage for that particular panel, then I like that would be what? The maximum voltage for what? That on the curve for the operating point. Not the maximum point, but the maximum voltage that the system can operate. Okay? Alright, so that's one point, okay. What is it used for? What we use this voltage for? The open circuit voltage is what? To determine what? The maximum circuit voltages for the what? For the modules, as well as what? For the arrays itself. Because what happens to those arrays, those modules that we're going to get? We're going to hook them in such a way it's either what? Series or parallel combination to obtain what? Voltage, a certain voltage, at what? At a certain amount of what? Current. Because again, the fundamental thing is what? To get power out of those modules. Okay? And I just repeating here that can be what? You expose the device to the sunlight and what? And you're measuring across the output terminals, okay? You gotta utilize what? DC multimeter, and again, you measure what? DC type of voltage. So you gotta make sure that you what? A lot of the guys that they go for troubleshooting applications, they go up what to the modules, and what they do? They take their wiggy and they start what? Measuring. No more wiggies in this job, okay? You're laughing, but it's going to happen one time that you will do it. So, but remember, you're dealing with what? Photovoltaic systems. There's one section of them. It's what? All DC. If you don't mistake it, the gentleman here, they show you what? DC type of what? Disconnect switches. Remember, DC. So now, for some of us, you take the actual physical here. You stick your. Is the polarity an important consideration? Why? What happens if I reverse the leads and measure voltage? What is that going to tell me? What's the difference between a negative 6 volts and a positive 6 volts? What is it? There's no difference. It's just the convention, the way you measure it. Okay. So this is clear how we're going to measure. What happened? You had a question? You have a question? Analog meter? Okay. Yes, they do. They do make analog meters. They do make. No, but voltage is voltage. It's actually the convention that we have used to measure a certain polarity, and the meters are calibrated in such a way that it says this particular lead is dedicated to the positive terminal, this one to the negative terminal. The construction of the meter itself defines that. But voltage is voltage. Okay. If it didn't matter which way we measure, then the concept would not going to be there. Okay. As any type of measurement, we have to establish what? A reference, a convention associated with that. Okay. Now, to measure the short circuit current, okay, there's a couple of ways we can do it. If we get a very sensitive meter, which is the actually resistance associated with that is very small, we can just plug it what? Across the line in here, and we can measure the actually measurements of the actually short circuit. We actually shorting through the meter. Guys, pay a little bit of attention, please. That you actually have, and you can have a meter that actually measures that. If not, you put a clamp-on type of meter. Most of you are familiar with this type, and you can measure actually. You're closing the leads up there. You can actually measure what? The current. Now, couple things, and we put that note in here. It says only photovoltaic devices, you can short them up there and actually measure the actually short circuit current. And it says in here, don't measure any other devices like that. Is this clear? What is the measurement? Yes, sir. Okay, the question was, what happened to the panels if I short circuit it and leave the leads on? What? Good question, and I guess suppose I take this panel up here, it has 2 leads up there. I take those leads and I short circuit them up there. What's going to happen? The question was, will it burn out the panel? Just think in the practical sense of application, okay? If you had a battery, and you short the leads on it, what's going to happen? Who said that? Who said it was going to blow up? Just think about it. If you take